Hi guys, let's look at the next question. The next question that we do is question number 5. It says two equal chords AB and CD. So let's see what we have been given. AB is equal to CD. Intersect at point P inside the circle. Prove AP is equal to CP. So again we know we have to draw a perpendicular on from the center to the chord. That's the only way to get these are the only properties that we know. So let's just start. I have drawn a perpendicular from O onto CD, and let me draw a perpendicular from O onto AB. Let's name this M and N. So this be M and this be N, and let's also join O with P. So let's just write whatever we did and see how this will help us. Number 2, join OP. Number 3, draw OM perpendicular to AB and ON perpendicular to CD. Let me just mark 90 degree. So I have drawn these two perpendicular. So what this gives me is since this is perpendicular from the center, it will bisect the chord. So since OM and ON are perpendicular to the chords, therefore OM and ON bisect the chords. So they bisect it. So what I get therefore is AM is equal to BN and CN is equal to DN. Let me also write the relation with the AB. This is equal to half of AB, and I get CN is equal to DN is equal to half of CD. But since AB and CD are equal, which means half of AB and half of CD will also be equal. Since AB is equal to CD, therefore half of AB is equal to half of CD. What this gives me is AM is equal to BM is equal to CN is equal to DN is equal to half of AB is equal to half of CD. So we've got the first thing here. What we also know is equal chords are equidistant from the center, which means therefore OM is equal to ON. Since equal chords are equidistant from the center, equidistant from center. Right? So let's look at these two triangles and try and prove them congruent. So in triangle OPM and triangle OPN, is there anything common? Yes, we have angle OMP is equal to angle ONP is equal to 90 degree. This is by construction because we've constructed it as perpendicular. Next part would be I have ON equal to OM, which means hypotenuse OP is equal to hypotenuse OP. So this is what I wrote first. So OP and OP is common and OM is equal to ON. This we got from 9. So I have a right angle, I have a hypotenuse and I have a side, which means therefore triangle OMP is congruent to triangle ONP by RHS test. What this gives me is MP is equal to NP, and the reason for this CP, CT, C. Now I have MP and NP equal, MP and NP equal. Let's see how does this help me get AP is equal to CP. Okay, I know AM and CN are equal, so let me just subtract these two. Okay, so number 15 would be AM is equal to CN. AM is equal to CN. This is from 8. So subtract 14 from 15. So what I get is AM minus MP is equal to CN minus NP, and AM minus MP is AM minus MP is nothing but AP, and CN minus NP is nothing but CP. So this is the first part of the question, hence proved. That brings me to the second part of the question. The second part of the question is I need to prove that BP and DP are equal. So BP and DP, okay, so BP is nothing but BM plus MP, so this time I add. So number 18 would be BM is equal to DN. Yes, is equal to DN. This is again from this time BM is equal to DN. This is from 8. And number 19 would be add 18 and 15, which means what I get is BM plus MP is equal to DN plus NP, which means BM plus MP is nothing but BP and DN plus NP is nothing but DP. That's what they wanted us to prove, hence proved. Done. Let's look at the next question. The next question that we do is question number 6, part 1. Let's read the question. It says OABC is a square. A circle is drawn with O as the center, which means OC at P and OA at Q. We need to prove that these two triangles are congruent. Let's just draw these two triangles separately and see what do we know about them. So these are the two triangles. This is O, this is again O, this is C, this is Q, this is P, and this is A. Now OA and OC are equal. Why? Because these are sides of the same square. Angle O here and angle O here is 90 degree because this is the vertex angle of a square. And OP and OQ are equal because this is the radius of the same circle. So let's just write that down. I think we've already proven these two triangles by congruent by side angle side test. So let's just write that down. In triangle OPA and triangle OQC. Number 1, angle POA is equal to angle QOC is equal to 90 degree. Vertex angle of a square. Next part is angle, or not angle, side. OA is equal to OC. Reason is sides of the same square. Done. And then the third part is OP is equal to OQ, and the reason is radii of the same circle, which means therefore by side angle side test, triangle OPA is congruent to triangle OQC. That's what they wanted us to prove, so hence proved. This was very simple. Let's look at the next one. The next one that we do is question number 7. Question number 7 says the length of common chord of two intersecting circles is 30 centimeter. So what's a common chord? So let's just quickly look at this. This is triangle, this is circle 1 and this is circle 2. Okay, so circle 1 and circle 2, they have a common chord. What would be that common chord? The chord which is common to both the circles. Let this be the center of circle 1. Let this be C this time. Let this be D. And common chord for both the circles is AB here. Now, AB is a chord for circle with center C, and AB is also a chord for circle with center D. That's why it's a common chord to both the circles. So the length of this common chord is given equal to 30 centimeter. Let me just shift it slightly. Done. So what is given is AB is equal to 30 centimeter. If diameters of the two circles are 50 centimeter and 34 centimeter, we need to figure out the distance between their centers. Okay, so what is given is AC is equal to radius of circle 1 is equal to 50 upon 2, which is 25 centimeter. Next, AD, which is radius of circle 2, is given equal to 34 upon 2, which is 17 centimeter. AD is equal to radius of circle 2 is equal to 34 upon 2, that's 17 centimeter. What we need to figure out is the distance between these two, which is CD. So let's just write that down. Number 4, CD is equal to question mark. That's what they want us to figure out. So these two lines are, this will make an angle of 90 degree. So number 5, since CD is perpendicular to AB, which means what we have is, let's give this some name, let's call it point E. CE bisects AB and DE bisects AB, which means AE is equal to BE is equal to 30 upon 2, which is 15 centimeter. So this part and this part is equal. This is 15 centimeter. This AC here is given equal to 25. AD here is given equal to 17. Let's apply Pythagoras theorem on these two triangles and we should be able to find CE and ED. So in a right triangle ACE using Pythagoras theorem, what we get is 25 square is equal to 15 square plus EC square. This is 625. 625 minus 225 is equal to EC, the square root of this. So this is 400, therefore EC is equal to 20 centimeter. Next, this is point 10. Point 11 would be in right triangle ADE using Pythagoras theorem. What I get is 17 square is equal to 15 square plus DE square. This is 289 minus 225 is equal to DE. This is 64, which means DE is equal to 8 centimeter. What they want is CD. CD is equal to CE plus ED, which is equal to 28 centimeter. So the question has, therefore the distance between centers is 28 centimeter. Good. Let's look at the last question that I'll do with you from this exercise. The last question that I do with you is question number 10. Question number 10 says AB and CD are two equal chords of a circle with center O which intersect each other at right angle. Okay, so let's just draw the circle first and let's draw two chords which are equal in length and they intersect at 90 degree. Done. So let this be the chord that I've drawn. Let this be AB and CD are the two chords. They intersect at 90 degree. The center of the circle is O and they intersect at right angle at P. So this is point P. OM is perpendicular to AB. So OM is perpendicular to AB and ON is perpendicular to CD. Okay, this is M, this is N, is perpendicular to CD. We need to show that OMPN is a square. Okay, so let's see how we can solve this. So first step, join OP. if I join OP, if I can prove these two adjacent triangles similar congruent, then I'll get OM and ON equal. And since OM and ON are equal, which means adjacent sides of this is in any case a rectangle because all three angles are 90. So if I can prove that these are equal, then I should be able to prove that adjacent sides of a rectangle, if they are equal, then this figure is a square. Let's start. So join OP. What I have here is in triangle MOP and triangle NOP. Number 2, what we have is angle OMP is equal to angle ONP is equal to 90 degree. This is given. Next, I have OP is equal to OP. This is common side. So this is the hypotenuse OP. And then the last one would be OM is equal to ON. OM and ON are equal. Why are they equal? Because equal chords are equidistant from the center. So equal chords are equidistant from center. Okay, which means therefore triangle OMP is congruent to triangle ONP by RHS test. What this gives me is MP is equal to PN. This is CPCTC. What I already have is, so let's just write quadrilateral MPNO is a rectangle since all vertex angles are 90 degree, and the next one, since adjacent sides of quadrilateral OMPN are equal, the adjacent side being MP and PN and MO and NO. This is from 4 and 6. Therefore, rectangle OMPN is a square because the square has adjacent sides equal and has all angles as 90 degree. Adjacent sides equal, all angles 90 degree. This is a square. Good, that finishes this exercise for me. Homework questions for you. Homework question for you would be question number 8 and question number 9. Thank you so much. Take care. Be safe. Bye bye.